So we're going to be talking about content and file providers in Android application testing. I'll apologize before the video starts. I haven't had time to rehearse this because it is right around Thanksgiving. I'm super busy with holiday stuff, and these slides are super thrown together. So as always, I'll recommend to just go ahead and dive into the, Xtree IO course and whatever other resources you find, especially the Android developer documentation, as literally everything you would ever want to know is in there somewhere. Um, so without any further ado, let's just go ahead and jump into it. So first, we'll talk about what a content provider is. And these are, they present data to other applications as a table. So, you can think of content by an app just as data inside of like an SQL database where you've got different tables. Um, each row represents like an instance of some type of data, right? The provider collects, or like the provider, which is like the client, collects a column, or how do I describe this? So the row is an instance of some type of data that the provider then collects, and a column in this row represents the piece of data that's collected for a given instance. So content providers coordinate access to your application's data storage for multiple different purposes, right? So you might share access to your app data with other apps. You might use it with widgets. You might want some of your app data to be searchable. Like, let's say you have a notes app, right? And you want your users to be able to search for that note just in their file systems, like like the Android operating system search, or on iOS, you've got like a search function. You might want it to show up in that search. Or returning, what else is there? There's the synchronizing app data with a server, which you can do through this thread sync adapter, cursor loader, which is like loading data in a URI. So this content provider kind of acts as this, again, right, the data storage layer, or lets your other applications, it coordinates access so that other applications can access the data storage for your application. A good way to imagine this is like, think of a social media app where you can add friends based on like whether or not you have them stored in your phone's contacts. So you might want to share that data, after prompting the user, of course, share that data in some way. Accessing a provider can be done kind of like this. So you have to use this content resolver object with your application. And before you can actually ask anything from the provider, you need to have the relevant permissions. So in this case, the permissions would be like this. So the read context permission, for example. And then in newer versions of Android, or it kind of depends on the version, you have to actually prompt the user for this. So in this case, this is just some logic. You can use it straight from the documentation where, using this upon launching the app, it would prompt if the user wants to grant this permission. And then if they do, and also having it declared here, would allow you to then query the default contents, the contents of this contacts content provider. And this is a little bit confusing, but we're going to see a lot more examples. And this is kind of a weird one because we don't actually say the explicit content URI, at least not in this screenshot. But basically, this would print out as something like content : // Android contacts / raw contacts. And everything after this, like the slash character, which we won't see for a little bit, acts as the columns. And you can think of these a lot like SQL statements for the time being. So let's say that our app, we just want to, query the content provider. This function down here, this kind of if chunk, is just meant to get everything printed so that we can see it in the text view. But this is just the contents of the this file provider, or not file provider, the content provider that we query. So when we specify null in each of these, null typically means like, viewed as like an asterisk in a SQL statement. So you're asking for everything that's there. So in this case, when we click this button, assuming that the permissions have been given to the application, it will just query everything from the contents or from the contacts file or content provider. So in this case, you can see all of these pieces of data are pieces of data that make up the contacts that are present in my device. So that's a pretty straightforward example of accessing a provider. The next thing that we're kind of going to segue into, and we're covering it in a weird way, is flaws that you might see with providers. So SQLite is oftentimes used for querying and fetching operations with file providers. So you might see SQL injection if your inputs in these different, in this cursor object, because these are passed in usually as part of the SQL query, you might be able to see that become an issue. Other things are implicit content provider access. So implicitly, it's similar to the implicit intent stuff, right? Where you have an intent that accesses a content provider or a file provider that is, able to be accessed and used by other applications, perhaps unintentionally. And then other things are like path traversal in like the URI. We're going to talk about that more with file providers as it's a little bit more relevant there. So first, we're going to talk about an example of interacting with a content provider, in this case through URI matching. So you'll see logic like this a lot. And then we'll eventually get to talking about how this can lead to SQL injection depending on the context. So in this case, you can see here's the authority for the content provider. You can see it just sets some variables. It has the secret, et cetera, et cetera. And you can see here's the URI matcher, so that when something is trying to query this content provider, it'll try and match whatever's in the content URI to one of these two things, and then use one of those things to determine the next thing that we'll talk about. So if it's flags at the end of the URI, it'll set it to 1. If it's flag and then some number, it'll set it to 2. If we look at the next slide, you can see when it's set to, I think it's 1, it'll say flags isn't implemented yet. And then when it's set to 2, it'll try and get the flag ID relevant to that. So again, this is meant to just allow us to construct an intent or construct a content URI that we can use to get these flags. In this case, right, we just say flags and we see the expected, flags not implemented yet, right, because it resolves to, flags resolves to 1 throws us in here. So if we change it to 2 and then specify the flag number, in this case, like flag 31, we should be able to see that flag come right through. Again, there's no SQL injection happening here. This is just the, this is an example of how you would interact with it by creating this cursor object and then just performing this action. The next thing that we're going to talk about is SQL injection in the content provider. So if you're following along, like in doing this, like with the X-Street course, you'll try and, query the flag 32 authority and ask for flags because it is implemented there. And without reading the code, you'll find that it prints out flag 30 and flag 31, but it won't print out flag 32. And we also see how this visible parameter is displayed here. So we can actually go ahead and look at what that means in the source code. And first you can see like, okay, this is how our SQL query is constructed, right? You can see these are our inputs, the URI, the, what do you call it? These different parts of the query, the projection, the selection, the order, I think it is. And you can see how I believe the selection that's here, the selection parameter is being passed into this query that verifies like, hey, the flags that should be output should have visible set to 1. If we look at the flag database helper that's used to determine some of these qualities, you can see that flag 32 has the visible Boolean set to false. So in order to actually get the flag to print out the way we want it, we're going to need to get around that logic. And we can do that because, right, this selection is being passed to this str string, and that's being passed into this query. So what we can do is perform SQL injection. So imagining, right, that this is our query that's going to be resulting because str, this selection right here, is being put right here inside these parentheses. We can then make it resolve to this. So visible is 1 and true, or visible is 0. So regardless of whether or not the items in this, the flags listing, regardless of whether or not this has visible set to true, it'll still, print it out. So it'll always return true. Pretty straightforward SQL injection. It's just the way that we're doing with these content providers is a little confusing if you haven't looked at it before. Next, we'll talk about a little bit more about like the access permissions. So when a provider or a content provider is being accessed, it'll have like this provider declared in the Android manifest. And you can see that grant URI permissions is enabled, but in this case, it's not exported. So if we're trying to access a provider that's not exported, we're almost always going to be doing it through an activity. And there's multiple alternate forms of provider access, but the primary one seems to be accessing it through an intent. So in this case, in this example, right, we're just querying the content provider as is because it's exported. But when it's not exported, you'll see that we kind of have to access it through this other activity. And we'll talk about it. I think I have it come up at some point. Maybe I don't. Let's go back to where we were. I don't know if I have it come up, but you can see here's the action and here's the activity we want to look at. So in this case, our provider is flag 33 activity 1, and it's expecting an incoming intent. So it wants the action to be set as flag 33. It wants you to give it this content URI. It sets the flag to 1. This is the constant value for flag grant read URI permission. So this will read, whatever is, this gives you read permissions for the whatever's in this content provider. Now, when this flag is set, the recipient of the intent, because, after it takes our, let's see, on create, it gets our incoming intent and then sets the, this flag and sets this content URI and then sends it back. So what we're going to do is create an app that sends an intent to this activity because it's exported. And then it'll give us back an intent that has the permissions we need to call the content provider that we would like to call. And so we can, we'll send the intent the same way we have in the past, which is just like this. So we specify, here's the action, here's the name of the activity, start the activity when we click, and then we'll handle the result, which is pretty similar. We just set it so that now that we have this result, we use our logic to interact with the content provider, and then use our same like utils to dump the contents of the content provider. It's pretty straightforward. But the issue is that we can't really get flag 33 with this, which makes sense if we look back at the database helper, because you can see that it's pulling from a different table. So previously, it was pulling from this flag table, and now it's pulling from this note table. I think if we go back, you can see here, we're using null in our cursor, so it's trying to get everything from our tables, rows, whatever. We can still get all the flags from last time. So imagine the query being run is like something like this, where we're using these nulls to declare everything. So, this maps back to that. If we look at our, flag 33 provider 1, you can see here that our projection, I believe this is being passed through. But you can also see that this, our projection and our selection is being passed through, but it's also being queried to this table flag table, which is not what we want, right? For this flag 33, we want it to be this note table. So then the question becomes, how do we change the table? And the answer is similarly, well, we know that if our projection is being passed through before it actually says which table it is, we can then, control that. So in this case, I don't think we can see it in this screenshot, but imagine that it's like from or select projection from table flag where selection and some other kind of constraints. So in this case, we could have this kind of logic in our projection. For this, we wrote it to a string separately and then pasted it in. But in this case, it's similar. It's SQL injection, but instead of modifying some condition to be true, we're actually changing which table we're pulling it from. So same thing, we're saying, give me everything from note, and then terminate the string. So in this case, it'll let us pull everything from the note object. you'll run this, you'll see that it pulls everything from the node object, and then you can see both the flag and you should be able to see everything else. But I'm not including screenshots of that here. Next, we're going to talk about implicit provider access. So again, this is kind of like you've got an implicit intent. So we need to start a non-exported activity. In this case, it's flag 33 activity 2 from the attack surface app itself. And then we need to posture our app to handle that implicit intent. So attack surface, user clicks this button or performs some action that sends an implicit intent to our malicious application. Then our malicious application uses some kind of flaw in the way that this content URI or something is handled to perform some action. In this case, you can see that it sends out an intent with this action and this content URI, adds the read flag, and then starts the activity and sends it over. So what we need to do is just create an activity that's ready to handle that kind of intent. So we say, here's our name, here's our scheme that needs to be set. Again, flag 33_2, so that it actually tries sending it to us. And then once that's underway, we can just implement our second activity, something like this. So check that the incoming intent has the correct action set. In this case, making sure the action is flag 33, making sure the data URI is content, et cetera, et cetera. And then making sure that this read URI permission is set. And then once it is, this same one is vulnerable to the same SQL injection. So we can then just dump node again and get the same issue. And that's all it needs us to do, is to just dump it. So the same logic is basically there from the last time. The only thing that changes is that when we handle our received intent, we're just performing it in a different spot. Next, we're going to talk about what exactly a file provider is. And it's kind of confusing. I think of them as pretty similar to content providers, just like more of a different type. But basically, there's more to content providers than just querying them like it's an SQL database, even though that's kind of how we've explained it. You can use them to open files. You might have seen this when you were looking through the documentation. We can follow along like the courses that are a part of the documentation, which will show you how you can implement code that queries for photos or videos, and even lets you, take photos and videos using an intent and then save it. But that's the idea, right? It's accessing the file system. Let's say you made an app that you want to use to edit photos, right? You wouldn't need access to every photo. You just need access to one photo at a time. But you would need the permission to write that photo back onto the file system once it's been edited. And what this kind of has to do with file providers, because so far it's not that much different. Think about there's a library or like a namespace called Android X, which is commonly used. It's got a bunch of like Jetpack libraries is what they're called. And these are commonly used by Android developers. If we talk about file provider, that's kind of what we're going to be talking about. So in this example, right, you can see the authority, the permissions, not exported. And then it's also referencing this metadata tag for this file provider path. And then it's referencing this file paths file in the XML directory. And if you go look there, you can see, okay, it's declared two file paths. One is flag files, and it's at the flags / this will start by default in the applications directory. It's like data, the app name, and then some directory, and that's where it is. So it has other files with a dot and then flag files. So in this case, the file path that this provider has access to or will give access to is just flags and then its own directory, which is typically pretty fine, but sometimes that can have worse implications, which we'll talk about. We can see how this is implemented in flag 34. So you can see it expects an incoming intent where if no file name is specified, it'll prepare a file path on files that contains this secret.txt down here. And then it then uses this as a parameter in this get URI for file. What do you call it? Method or function. And then it inserts this into intent2, which is given read permission and then sent back to the calling app. So kind of similar. This is also exported, so we send an intent to this activity, and then it should send one back that will give us this. And notice it has 3 set here as the flag. If I scroll back enough, you'll see previously it always added 1. That's because the permission that it's adding is I believe it's, let me see if I'm looking through my notes here. The 3 Boolean is for read and write permissions to a directory. So we'll talk about that in a second. So it gives read and write permissions to that directory, or whatever it has privileges to, and then sends it back to our application by way of an intent. So you can see here's how we might perform some sample interaction. Again, normal intent interaction, right? Just create an intent and send it to this app. It doesn't need to have any special details in it in this case. And then in this case, when we're talking to the application, or once we actually get that intent back, we can actually just make it so that the debugging is a little bit easier. So we log the URI that's incoming, and then for the input stream, we can buffer that out so that it shows us the contents of whatever it's reading for us line by line. So in that case, you can see that same implementation here in the main activity. So when we get that intent back, it tells us the information that it has. In this case, right, just as we expected, it sent us this content URI for secret.txt, and then we can actually see the output here because we have the read permissions as part of that flag number 3. Now, there's certain insecure file provider configurations. Again, there's another oversecured article that goes into more detail about this, but basically, this is pretty standard, right? Where you have other paths or other files is equal to this, and then, it's not going outside of its own realm, so to speak. But an issue you might see is that, it might declare the root path. It might declare some files and cache directories that other apps might implement or might manipulate. And again, not just read permission, but also write permission could be dangerous here. So first, let's show off an example of where the root file provider is being used. In this case, you can see that it's not exported. Here's the authority. It's giving grant read URI or grant URI permissions. And then you can see this root paths is set as the metadata, or for like the file provider paths. And this is like the entirety of the Android operating system. Not a good idea. You shouldn't let, clients for your content provider perform this. Even though it's not exported, we can access it using that same intent that we used earlier, which was, I believe, right, it was a flag 35? Like 33 activity 2, we might actually just use the same one. So you can see here the file provider is just kind of a wrapper. It doesn't do anything special. And then the activity itself is designed to basically do pretty similar to what happened last time. Take our incoming intent with this file name parameter and then send it back with read permissions, except in this case, right, it's read and write permissions. Allowing the calling app to read a file. But in this case, it's everything in the root directory. So as long as we point this to the correct spot, it'll perform whatever logic we want. So again, point it towards flag 35, set the file name to this specific flag, and you'll see that it doesn't work. And that's because there is no file called flag35txt within that directory, but because we have root file access, all you would have to do is change the path until you actually find it. So you could, theoretically look through everything, all the different paths, and look for specific files if you know what the file you're looking for is called, and read, sensitive files that are on the file system. So again, this is what those permissions would look like. So in the case of it using 3, like that number as the integer, that's for both read and write permissions. I'm pretty sure 1 is read, 2 is write, and 3 is both of them. And those are just the constant values. But of course, in flag 35, we have the ability to write any files within the root directory, and we can practice those write permissions by trying to solve this flag 36 activity. In this case, it looks for this Boolean in like this flag 36 preferences file, and checks to see if it's set as solved. If we use like the ADB shell, we can actually find the file that it's talking about and see where this X in the XML for flag 36 preferences that it pulls from. this is solved being set to false. So what we want to do is leverage the write permissions that we have in flag 35 activities content provider, or in the intent that flag 35 activity gives us, and then use those write permissions to change the contents of this file so that flag 36 activity returns true, and then we can get the flag. So again, we call the intent, and then we set our extra as file name to do this whole traversal stuff outside of the root directory or outside of the application directory into this attack service shared preferences. And we say, hey, we want to manipulate this file. And then this is some ChatGPT generated code for using parcel file descriptor. But what we want to use is this buffered writer. So then we're just basically writing over the entire contents of the file, just changing solve to true here, right? So that's the only thing we're changing, so that that resolves true, and then we can get the flag there. Those are the examples I wanted to showcase. It's really just what kind of things you can do in the examples that are shown in the course. Of course, I'm leaving some of them out, but those are the examples I wanted to go over. And then to wrap up here, these are real examples. Like if you look around in HackerOne and a few other bug bounty sites, you can find examples of this. In this case, this is like a $500 critical severity bounty from 4 years ago. There's not a ton of Android stuff because it seems pretty niche, but you can see here that there's a content provider that is or a file provider that's scoped to allow for this root path, not root path, but all of the application data to be accessed. And because of that, this person who submitted this report, which you can go read, showed that you were able to actually get the cookies and use that to, take over an active session if you had all their session cookies, which hence, is why it's a critical vulnerability. I don't really think the bounties are reflected at this kind of price point anymore because of the Google Mobile Vulnerability Research Program trying to get more hands on deck as far as that's concerned. But really, that's all we've got to go over today. Thanks for tuning in. And be sure to actually follow along on that course because the quality there seems to be pretty well done, in my opinion.